All right, so next lesson is a few more a few more terms to look at. So, outcome, we're going to discuss what it means. What does it mean to be collinear? And coplanar. So collinear means to get points together on a line. So basically, if you can put a line, this is what I tell my students. You can put together. That's right, isn't it? See, now it's gonna bother me. 1 second. Yeah, that's the right way. Okay. So basically, as long as you can put a straight line between the points, it's collinear. So let's take a look. Points E and C. Well, E and C already have a line through them, so that's definitely collinear. And ignore my bad spelling there. We've been looking at my other videos. You'll know I'm not my math teacher. Sometimes I misspell things incorrectly. AGID has a line through it as well, so that's a big old yes. AFD. If you look at A, F, and D, there's literally no way you can put a line through all three of those without it bending or breaking. So you go A, F, and then you'd have to swing back up to get D. So that would mean it's not collinear. You have to have a straight line for it to be collinear. So the answer is no. Now, here's where it gets interesting, because this is where some of my students will get it wrong at first. So points J and G. So it's not that you have a line already through them to be collinear. It's that you can draw a straight line through them. And J and G, you can draw a straight line through them. So it is a yes, J and G are collinear. So it comes down to one of our conclusions that we can automatically put down, and that is 2 points are always collinear. Just like 2 points can form a line, it's always got to be collinear. That way, with Fi, I don't even have to check it on the diagram. F and I being 2 points automatically is a yes. So anytime you see 2 points, it's automatically collinear. Then H, J, and A. If you look, the same deal as A, F, and D. You can't put a straight line through them. The answer here is no. Okay, so that would be my collinear. Well, what's the other part? Well, the other part is coplanar. Coplanar is like collinear, except for being together on a line. We have points and lines together on one plane. And remember what a plane is. A plane is a flat surface like this piece of paper. If I can draw it on there, it's going to be, if I can basically fit this rectangular piece of paper around the objects, then it's going to be coplanar. Now the problem with this one that a lot of people have an issue with is a lot of these drawings are drawn 3-dimensionally on a 2-dimensional surface. So a lot of people are like, well, they're all on a plane because they're all writing on this paper. But, okay, you have to kind of think outside of the box and note that it's actually supposed to be in 3 dimensions. Like, for instance, this diagram here, we have everything laying on this flat surface except this line HE that goes through the plane. So that HE is literally sticking up outside of the paper. Therefore, you have to be careful. You have to superimpose it in your mind. Now, if I look, D, E, and F, well, they're all on that line, and so that line is on a plane. Therefore, they have to be coplanar. Then DF and G, again, DF and G, they're also on that flat plane there. So yes, they are coplanar. Now let's talk about H, E, and F. Now it's going to be the same rule as collinear last time. So if you can put a flat surface around it, then it's coplanar. Just like a collinear, it doesn't necessarily have to already have the flat surface around it. So if you can put a flat surface around it, then it can be coplanar. That's why I tell my students to kind of envision a triangle. Can you put a triangle, a flat triangle around those points, and have it be still flat? And the answer is, in this case, yes. You can actually make H, E, and F the points of a flat triangle. Granted, it would be a triangle sticking up in the air, and that's fine. So basically, the triangle will be pointing up, kind of flat like this, and pointing up. But it's still coplanar, so we hit a yes on that. Okay. G, E, and F. So once again, G, E, and F. Oh, and H. I apologize. G, E, F, and H. So this is where it's not coplanar. So you already have E, F, and H. They're already triangles. If you try to get G, basically if you try to go out here, it basically changes it into kind of this triangular pyramid type of situation here. So a pyramid, like the pyramids in Egypt, are three-dimensional. So once you go out and try to get that G, it becomes a three-dimensional solid. See if I put them all back? That's a three-dimensional pyramid there. So the answer here is no. Then you have DF and HE. Well, DF and HE are going to be coplanar because they intersect and form that that plane, the make a plane. So the answer is yes. Now I'm gonna throw a couple more things down here just to see if my math students, my geometry students watch these videos. I did give them a couple in class, but I'll give you a couple more here. So what makes things coplanar? Well, the things I gave in class, I said any 3 points are coplanar. I also said anything that is collinear is coplanar. Here's an extra one that I didn't give them. Any set of intersecting lines, if they intersect, they're coplanar. Okay, one I did give them was a line and a point off the line. Okay, and parallel lines will also be coplanar. In fact, if you remember, if you're watching my videos, you watched my last one. I said parallel lines, the things we gave where they just don't intersect. It's technically it's a good enough definition for the time, but it's technically not the actual definition. The actual definition of parallel lines are two coplanar lines that don't intersect. So two parallel lines are also coplanar. And really, the big thing we got here that's not coplanar is skew lines. Now let's see if they check this video out. Hopefully they will. So got that. So I got my last little practice thing here. So the only thing that's flying up here in the air is F. Let's talk about what's collinear and what's coplanar. Well, automatically, without looking, I know that A and D are collinear, and I know that F and C are collinear, because again, they are 2 points. All 2 points are collinear automatically. ACB is on a line, so that is collinear. CBF, that's not going to work out. That forms a flat triangle, which we'll talk about again when we get to, well, maybe we will, when we get to coplanar. So that's a no. And ACBD, again, there's not good, if that's going to have to curve to get it. So the answer there is no again. It has to be a straight line. It cannot curve at any point. Are the following points coplanar? Well, if any 2 points are collinear, and we just said that anything that's collinear is coplanar, that would mean any 2 points are also coplanar. Something to kind of think about. Now, a line A, B, and a point F. Again, a line and a point off of the line is automatically coplanar, so I don't have to look that one up. That's what it is. A line A, B, and lines formed by F and B. Well, once again, I just said that if they intersect, they're going to be coplanar. So these would be coplanar, and you can also see it kind of forms, if I do this, it's going to kind of form that semi-triangle like that. So we get a yes on that one. A, C, B, and D, well, they're all contained. Here's A, C, B, and D. They're all contained on this plane. So the answer to that would also have to be yes, because they're all on this particular plane. So in reality, the only one that doesn't work is A, C, D, and F. And the only reason why this doesn't work is to go get D, it has to become that pyramid-like shape again. It has to become three-dimensional. So the answer here is no.